I'm the building science manager for the Henry Company on the East Coast. I'm actually reside in Maryland, but let me minimize this. So some of these slides were introduced by PPSI. So the Henry Company is now covering the full building envelope, and so not only air barriers and plaza deck waterproofing and vegetative roofing. I actually have just a quick slide on sort of the history of our waterproofing, because a lot of people know us a lot for our air barriers, and we've been in waterproofing since 1967 with the introduction of our 790-11 hot rubberized asphalt. We also have our own water.
I'm sorry, that's
You may want to mute your mic if you can. So we also have our own water stops that we've had for a long time. There's sort of a chronology of some other waterproofing systems, and then we decided to release this pre-applied blindside system during the pandemic, so about a year ago, and we've had great success. So it's been sort of the missing link or the missing piece of our building enclosure portfolio, and these are a couple recent projects. Well, that was in the summer over here. This is up in a school up in Staten Island, and this is the picture to the right is another school up in Cambridge, Massachusetts, at MIT. I took that a couple weeks ago up there in a little light snowstorm. So this is AIA. We'll keep it fairly generic and clean, but the intent is to provide education. So with that, both myself, Brian, and Steve have a lot of history and knowledge with these deep foundation systems. And so this was a warning that this presentation contains graphic images of real life job site conditions. Viewer discretion advised. It sort of reminds me of a presentation that I've assembled over the years. It's sort of a raunchy title, but it's basically real world circumstances of what actually happens on job sites. So that's what a lot of this is. So the learning objectives, I'm going to go through some brief industry definitions, what are pre-applied waterproofing systems, some installation and critical details, and some warranty requirements and quality control, which are really critical because you can have a great system, but if it's not installed properly, it doesn't really matter. So we have a very good QA, QC program and a good warranty program as well. So some definitions, this is somewhat elementary. There's both positive side waterproofing and negative side waterproofing. So positive side is the same side as the source of the water. So you're basically putting a system on the same side as the source of the water. So inversely, negative side would be the side opposite the side or opposite the source of the water. So that's not really the way you want to lead your design, but if it's a retrofit and there's no other option, then you're looking at the negative side. So there's both pre-applied and post-applied systems. So what we're discussing today are pre-applied or blindside waterproofing systems, which are also positive side. So the systems are on the same side as the structure as the source of the water, but they're installed prior to the structure. So you've got this sort of gray appearing system here, which would be under slab waterproofing, and then vertical waterproofing. That would be your pre or blind side waterproofing. And then post applied is either you cast a wall, you let it cure for a few days, and then you post apply a sheet membrane, or in the case of negative side, that's also a post applied system. So if people have their mics on, if you could turn those off, that would be great. So pre-applied waterproofing systems, why blindside waterproofing? Brian, do you want to comment on this slide here?
Yeah, so what you're looking at isn't cars or a parking garage, it's dollars to the owner. So as you guys know, when you go to get your permits for this, it a lot of times is dependent on how many parking spots can you slam underneath this building. The parking situation in DC is pretty crazy. I think there's a parking spot, at least it was about a year ago, in Georgetown in a garage that you could purchase for the low price of $80,000 to get a deeded parking spot. So these parking spaces generate a ton of revenue for the building owners. So that's why we do blindside waterproofing, because we need to push these buildings out so far to the property edge so that we can fit in 1 or 2 more parking spaces. And this will come up a little bit later too about some of the issues with blindside waterproofing and why we see leaks. But this is the main thing: is everybody needs this space for generating revenue, but also a lot of times the number of spaces is a requirement based on the permits that are being received.
Yeah, and a case in point with parking garages, a lot of times owners like to have a well-lit parking structure or parking garage, hence the lighting, etc. So painting the walls white is obviously going to make it much brighter in appearance. And if you have vapor or water pushing through that foundation wall, then the paint is going to fail. So that's another reason you want to keep water and vapor drive away from those walls. So this is a quick little video just showing sort of a graphic approach of what a pre-applied system is. So you've got I'll just pause it here, the black material. Well, you got the foundation, and then you've got your supportive excavation, or SOE. So in this case, it's timber lagging with tiebacks, which we'll cover as well. You got a drainage composite. The white is a waterproofing system. So I'll just, and it rolls itself out. No, it doesn't roll itself out. But a couple other critical points here are these black lines. So this little black line right here is a water stop. So it's very important to have water stops in both construction joints and cold joints. So when you have one big element like a slab and there's multiple pores, you need a water stop at each cold joint. So when a pore meets the other pore, that's a cold joint. And then also there's a construction joint. So this next little black line that gets dropped in there conveniently between the slab and the wall, that would be a construction joint. So another critical spot for a water stop. And of course, if it's from the same supplier as the waterproofing system, that supplier can likely provide a single source warranty. So anyway, just another little aspect of this graphic, and then the wall gets poured and you're done. So that looks pretty simple and clean, but as Brian and I will share with you, it's not always that simple and clean. So basically there's both active systems and passive systems. So we've got positive, negative, pre-applied, post-applied, and active and passive systems. So active systems would rely on hydration and compression. So that would be your bentonite type systems. Passive systems are basically waterproof membranes, like a high density polyethylene, a polypropylene, a thermoplastic polyolefin, or TPO. Lots of chemistry or alphabet soup there, but basically it resists water right out of the gate. It doesn't require hydration. It doesn't require confinement, anything like that. So then, the way these systems interface with the concrete is very important, because prohibiting lateral water migration is of paramount importance. So you can either have a mechanical bond, you can have an adhesive bond, or you could have both. So with a mechanical bond, that can allow for lateral water migration. So if you have a geotextile with a sodium bentonite in that geotextile, it's going to bond to the concrete mechanically, but water could potentially migrate laterally. If you have an adhesively bonded membrane, that's good for prohibiting lateral water migration. And then there's a technology, it happens to be ours, it's a hybrid technology that offers both mechanical and adhesive bond, which if there's time at the end, we'll cover that a little bit more. So these systems are pre-applied prior to the structure and for both under slab and vertical walls. So this little diagram here, if you have a crack and the water gets in, if the membrane's not fully bonded, then that water can travel to find a way into the building. So you don't want that. So here's a couple of pictures of some horizontal or under slab applications. Some systems require a mud slab. So what these gentlemen are working on here is a little cracked and whatnot, but it's not a structural slab. It's just basically a working surface to get the work out of the mud, hence the term, mud slab. Some systems can go on compacted earth or compacted gravel. So that's going to vary by your manufacturer. And then again, here the systems can also go vertically. For walls, you got sheeting and shoring here. You got a cement board as a substrate that's going over the the sheeting and shoring. Brian, you want to comment? I believe this is a secant wall here in that picture.
Yeah, that's up in Boston, and that's more typical up there. We don't see that too much down in this market in terms of SOE
construction. Right.
Yeah.
Okay. I wasn't sure if there was something else you wanted to add there. So why is the reason for most leaks in blindside waterproofing? So Brian, you just tell me when you want me to forward.
Okay, you got it. So basically what we're looking at here is the sheeting and shoring guys. These guys are, 90% of the problems of the waterproofing leaks. And the reason being is they have one job and one job only, and that's to hold the soil back. They don't care if the building leaks. They don't care if they provided a smooth substrate. They have basically been contracted to just keep the soil from falling in. They're retaining the earth. Go ahead, Todd. The critical details, the academic part of this is gaps greater than ½ inch require substrate preparation. This can be drain board. In a lot of cases in DC, it's drain board, but let's say we don't have drain board. Plywood, spray foam, those types of things can be used for this. Typically I don't see spray foam used a lot because while it's an academic way to do it, spray foam doesn't typically expand out to a nice flat substrate. It kind of looks like the surface of the moon as it expands, and that doesn't really give us a great smooth substrate to attach to. Go ahead, Tom. So this is what we want to see. If I saw lagging like this in DC, we probably would never have any leaks. This is amazing. So if you go to the next slide, Todd, this is typically what we see. So again, these guys, they're not concerned about how you're going to have your waterproofing applied to this wall. They're concerned about the substrate or the soil falling into the hole. So they're going to do whatever means necessary to make that happen, whether that's going to be whales or rakers or tiebacks or whatever needs to be. And a lot of times they are not even anticipating all the things that they're going to need because they'll dig in and find they have problems. And we'll see some of that in a little bit here. Go ahead, Tom.
So Brian threw out that term, a whaler. So this horizontal beam here is referred to as a whale or a whaler. And when we see a raker is basically a diagonal strut that would go from the soldier beam or down to the foundation, and then there's all kinds of cross lot bracing and lots of crazy stuff. So how it is drawn? There was nothing in this slide.
Yeah. So the how it's drawn, you guys typically draw straight, perfect everything. And if you go to the next slide, Todd, I've never seen any architectural details that show this, right? Because you guys are just drawing, it's going to be perfect lagging and turning. A lot of times what happens is they drive the piles miss because they can't get all the way back to the property line, or there's a building right next door, or whatever the case may be. And then we have to do this. Now, remember we said we need a smooth substrate to install the membrane on with no voids. Here's what you come to the job site. Okay, make it watertight. So this is some of the things that, we see on every job. It might not look exactly like this, but it's pretty close. So go ahead, Todd. What about mid-lag, back-lag piles? You can see the lagging boards look pretty good, but now all of a sudden we've got a mid-lag pile, which means the lagging board goes to either the middle of the pile or the back, and we've got a waterproof around all of that. You'll notice the tiebacks. those tiebacks all have to have some type of detailing over it because they're giant straws coming through the waterproofing. So they have to be detailed. So how do we detail that? So if you go to the next slide, Todd. So one common solution to this is building up these, kind of wood cants so that we can take the membrane and smoothly go over it. We can make special field fabricated tieback boots to go over the tieback that you see there. So that's the easy solution until our friend the structural engineer gets in the way. So if you go to the next slide, Todd, you'll see this a lot of times where because they've missed with the pile, that wall's only 12 inches thick. So they have to run the rebar through the pile and incorporate that pile as part of the wall. So if you picture how our waterproofing now, we can't go around this pile because we have rebar that needs to go through it. The structural engineer will dictate that. And then the other solution to this would be, well, if we can't run the rebar through it, now we have to thicken the wall at that point. And if we thicken the wall, even by an inch or 2 inches, that screws up the jam-packed parking that we have down there, and that could impact the approvals that we have in order to build a building, because now we've reduced the amount of parking because every 12 feet or 20 feet or 16 feet, wherever these are, the wall gets thickened out by 3 or 4 inches. And I was always amazed because we'd sit there and say, can't you just thicken the wall? You know, what's 3 inches? And we got kickback from the design team, the builders, the general contractor, because that would impact the parking and that would mess up their zoning approvals for getting this built. So you go to the next slide, Todd. And then even if we could do that, how do we get around this? You know, you can see a PVC pipe coming out. You can see this braided cable, which we'll talk about. You know, this would just allow water to bypass the membrane. So these guys, these sheeting and shoring guys, they're doing everything they can to hold the earth back, but they don't necessarily or aren't necessarily concerned with making sure we have something we can waterproof. So go to the next one, Todd. Whales with tiebacks, talked about this. If you'll notice, they're right in the middle. You'll see the threaded rods coming through where the membrane would be. This becomes a problem. These have to get detailed properly. The way to do this is to leave blockouts around them or box outs around them so that they can be cut out after the wall is poured. But that doesn't necessarily always happen. If you go to the next slide, Todd, we see this a lot, and we come back, everything's poured, and we say, well, how is this detailed? Oh, we just, industry term, pookied it up with as much liquid as we could. And that thing leaked from the day it got poured because it wasn't done properly. Next slide, Todd. Temporary power. So a lot of contractors will take temporary power, run it down the wall in the site, and they'll strap it tight to the lagging. Well, if you think about what the membrane has to do to get over that, we can't necessarily just run the membrane over top of that. So it would have to be, you know, some of those wood cants built around it, so we had a nice smooth substrate. Or what we see more often now is these contractors are starting to use standoffs where we would detail each of these standoffs as a penetration in the wall, and then they would pour this into the wall, and that would just be abandoned there, that conduit. But at least it's a way to detail this properly. Go ahead, Todd. So we finally got one with no tiebacks, yay. This is down by Nationals Park, and this is, they couldn't use tiebacks because of the subway, the metro. So you can see in this picture, you can barely tell there's a excavator down underneath this. They couldn't even lift the arm of the excavator up. They just had to slide the dirt and get something else to pull it because there was so much steel in this. Now, this is important because when a contractor goes to bid these jobs, they're bidding mostly how many tiebacks or something along those lines, or a nice long flat wall. And if they don't know that there's going to be hundreds of these penetrations, it's going to be a huge change order. So these pose a couple different problems. One, you've got hundreds of penetration through the membrane, and two, it may be a large change order to the owner because of the way that this was built. Go ahead, Todd. Structural engineer, again, our friend. Now he comes out and says, oh, we have to have Nelson studs to hold the wall in place. So now look at every one of those Nelson studs. They have to detail around every single one of them and put a water stop around every single one of them. I know for a fact on this job, the contractor did not pick this up, that all these Nelson studs were there. And I can tell you that it cost the installer a lot of money in detailing. It probably took him 10 times longer to install this than it would have if it was a nice smooth wall. When you're talking about labor charges, that's a huge nut. Go ahead, Todd. What about underpinning? We see this a lot. We're building right up to the building next to us. So here's a typical spec. Interior surfaces of cut rock and concrete auger pile retention walls should be planar. Now that word planar is kind of a bogus word, right? Because what does planar mean to you? What does it mean to me? What does it mean to the guy doing the sheeting and shoring or the underpinning? In this instance, the guy doing the underpinning thought this was planar. And it you know, if you picture hanging a sheet of membrane on that and you're going to pour concrete up against it, it doesn't matter what sheet you put there, the chances are it's going to tear. So we talk about what is a planar substrate, how do we get it planar, what do you need to do, how can it be fixed? It's a big issue that we have, and making everybody on the same page, and that's why we want to do pre-con meetings also to get all this out, and we'll talk about that in a little bit. Go ahead, Todd. Again, discontinuous piles. These are things we see on every job. If you went through my phone, you would probably be horrified with all the different pictures that I have of conditions like this. In situations like this, we'll typically use the piles as the waterproofing, where we would terminate to the pile. But in this case, we couldn't do that because those piles don't connect. So how do we get that to be waterproof, watertight? Comes another big issue. Go ahead, Todd. Bracing too close. This is a real big issue. The one on the left, we see somewhat. The one on the right is pretty much a common occurrence. Anytime we have whales, the bottom piece is actually temporary. That's a kicker that they're most of the time they'll cut out prior to because they don't need it. They just need it as their temporary support. But how do we get waterproofing in and around all these little things and get somebody's hands in there to detail around it? It becomes a big problem. So we've tried working closely with the sheeting and shoring guys and have met with several of them trying to figure out what what we can do and what we need as far as requirements for waterproofing. And some of them have listened, and we're working with others as well. So go to the next one, Todd. Allowing room to work. So this, about 5-6 years ago, maybe longer, we started importing our steel from other parts of the world. And the steel from everybody I've talked to wasn't as high quality. And what happened as they were driving piles, it happened a lot, that as soon as they'd hit some rock, the piles would twist, bend, and you don't know that till you get to the bottom of the hole. So they get to the bottom of the hole, and now they have to figure out how to keep all these things in place. And in this particular instance, they didn't weld any type of standoff on that. And how are we going to get our waterproofing in and around that bracing that's way too close? So these are a lot of the things that we see that cause the leaks. If you go to the next slide, Todd. We see changing conditions. Lagging starts off looking great. Towards the top, it's been there 6-7 months. Those lagging boards start bowing out because of all the pressure of the soil behind it. And again, we talked about you can have a 1/2 inch, maybe 1 inch out of plane in order to address this. So keeping our eye out for things like that is another big issue as the conditions change over time. Go ahead, Todd. Tube breakers, my favorite. This is in Alexandria. So if you can see, they have these holes and the red circle on the bottom. It's actually how they pick them off the truck. They put these hooks into the into those holes.
10-month-old that's been like in and out of daycare.
The problem with this, though, is as we pour the mud mat or we pour the slab and we waterproof this under slab, those holes have to be welded watertight by somebody. Because if not, that water will come right up that pipe and into the slab and bypass our membrane. So who welds it watertight? You know, who even thinks about that? This building leaked from day one in the under slab, and this is the reason why. So we start thinking about things like this. What are some of the issues? Yeah, these are a lot of the issues, and it's not caused by the person installing the waterproofing, and it's not caused by the manufacturer. Go ahead, Todd. Finally, we get some help. There are a couple sheet insuring guys who have decided that they were going to put a whale between the two piles and recess the tiebacks, which was amazing. Then they could put plywood over top of it, and we had a nice smooth substrate. Problem was that the tiebacks weren't recessed far enough, so they stuck out past where the plywood would be a little bit. So we came up with this nice little detail where we put different sizes of plywood over it, so we have something nice and smoother to transition to. So if we put drain board over this and we put our membrane, this works out really well. So we're starting to make some progress with these sheeting insuring guys. Hopefully we'll make more as time goes on, but this is a good start. Go ahead, Todd. Expansion joints. This is one of my babies. So if you've ever done a job with a below grade expansion joint, you run the risk that the joint falls exactly on a tieback or on a pile with tiebacks. So you have an expansion joint. How do you get that expansion joint to sit flat on the pile and then get around all of those tiebacks? So we came up with a solution for this. If you click the next slide, where the contractor actually builds a metal box to get over top of it. It's canted on all sides, and then we have the expansion joint that actually gets factory fabricated to match the dimensions of the box in the field, and then they can install it and we can get that expansion joint up and around that entire tie back, toe tie, whatever's in the way. Go ahead, Todd. Installation and critical details. Best practices give you, say we want six inches between pipes. Pepco's going to give us 1.5 inches, and there's no argument about that. That's what it is. So how do we detail around that? If you go to the next one, Todd, this is typically what we see. Think about a person's hands trying to get in detail in between each of those pipes. Some of those are, not even 1 inch apart. So the real world, we talk about how are we going to build this? Are we going to box the whole thing out? Are we going to stub in pipes where the contractor will be able to detail around each individual pipe and then they plug a next pipe in? These are a lot of the things that we see that cause the problems with leaking. Go ahead, Todd. Soldier pile tiebacks. Yeah, there are tieback boots. That's the easiest way to do it. If you go to the next one, Todd. You're on mute, Todd. Still on mute. Yeah, still on mute. All right, we'll just go to the next one. Braided cables, that's another big issue. Braided cable, you can never seal a braided cable. You can't get between the braids. Doesn't matter how hard you try. And we always say you can't penetrate the membrane with braided cable. It's got to be something solid and then welded to braided cable. I've sat in countless pre-con meetings where the electrician said, that's impossible. You can't do that. And I show them these pictures, and then they kindly sit back down and say, okay, we'll do that. So it's possible. We've seen it done 1,000,000 times. We can't penetrate with braided cable. If you do, go to the next slide, Todd. You're going to get a leak, and you can't ever fix that leak. Kind of a side note also, we always see the electrical room, and we always see the equipment right up against the wall, right? It's fastened to the wall, it's tight to the wall. And if you get a leak, guess what happens? It's almost impossible to fix it because the equipment's in the way. So we always ask in the design process if you could hold the equipment off the wall, 2 feet, 3 feet. There's never room to do it, and it never fits in the plan. And I get all that, but just for fixing leaks in the future, if you had space behind the electrical equipment, a person could get back there, and they could also would be able to grout inject. The other part of this is if we do have leaks and the equipment's right there, you really don't want to mix a lot of water with your electrical equipment. So if you can keep it off the wall a little bit, at least you'll have a buffer where the leaks will drop down and maybe not get directly into the equipment. Go ahead, Todd. Rebar too tight, there'll be an independent inspector involved, making sure that the rebar doesn't touch the membrane. This is not only a waterproofing issue, this is also a structural issue because the structural engineer is going to require some amount of coverage of that rebar or the concrete. Go ahead, Todd. What about drainage? We see this a lot. Drain pipe, the correct drain pipe, tape over the front of it so that when they pour the concrete, it doesn't fill up with concrete. If you go to the next slide, this particular sub had the tape on, no problem, but they used the wrong pipe and the concrete crushed it, filled up the pipe. Now you're trying to get water to weep through this pipe into the below grade system. Go ahead, Todd. Weep not properly connected, making sure that all the connections are made. Go ahead, Todd. And then we get to our iron ochre. This is the DC bacteria. This is the cause of several leaks in DC because it's like a bacteria that grows. It'll clog up your drain system. That's why we want hard connections in the pipes. The main thing with this is that if you have iron ochre on your site, or you do, you should always incorporate cleanouts, lots of cleanouts that can be jetted out on a regular basis. Go ahead, Todd. And the main reason is if you don't, this can result. So this was a cord hole in a site that was a drained site. And why is that important? Because if it's drained, that means they can build the wall for non-hydrostatic, which means it doesn't have to, have as much strength. It's not, the design isn't as much. If your cleanouts aren't there, and if your drain system gets clogged and you have water pressure building up on the outside, yes, it's going to leak. But what does that do for your structure that is designed for non-hydrostatic pressure, which now has 15 feet of head pressure on it? So that becomes an issue. This wall, they cored this, and that thing just leaked like that for 10, 15 minutes, just on a non-hydrostatic design. So they had to go back, and they now have to jet out their cleanouts once every 3 months, once a quarter, just to make sure that this doesn't happen in the future. So that becomes a big issue with this, and not only for iron ochre, but just in general, making sure you keep your building at non-hydrostatic if it is non-hydrostatic. Go ahead, Todd. Transitions at critical details. The beautiful part about this is there aren't many below grade manufacturers that are able to tie in from their below grade product to their plaza product or to their air barrier product. And as we keep this AIA appropriate, there are a couple, wink, wink, nod, nod, that can now do this. So the details are pretty basic. It's been kind of the same detailing, but now if you use a manufacturer that has this, there's no finger pointing. If something's going to leak at this transition, you're calling one company, not several companies. So that's an important designation when specifying that the plaza waterproofing should be the same as the below grade waterproofing, same as the air barrier. Go ahead, Todd. And here's what that detail looks like. A lot of people would look at this and say, man, that is ugly, because it doesn't look pretty, right? My entire life has been spent dealing with things that don't look pretty but make the building watertight. To me, that's gorgeous. That's a lot of hot rubber tying into a below grade waterproofing. And as far as neatness goes, yeah, it might not be an A, but as far as water tightness goes, it's an A+. So that's what we're looking for, is a watertight structure. Go ahead, Todd. Scheduling issues. So I don't know when this started, but it's now the day we put the shovel in the ground, we're now behind schedule. So every time we do a pre-con meeting, every time we do everything, we're behind schedule, we're behind schedule. So to that end, the GC is always instructing the other trades to hurry up and get their work in, and nobody ever thinks about, well, how do we tie this in or how do we tie that in? And the other part of this is a 3D transition detail. So I guarantee that this was detailed showing below grade waterproofing. One detail showed below grade waterproofing going to the brick shelf, and another detail showed below grade waterproofing going to plaza to hot, but they never showed what happens at the corner where the two come together. So they left a tail where it ties into hot. They brought the membrane up where it ties into the air barrier. They instructed the stonemason or the mason to go and start installing his CMU and his brick. And we didn't tie this waterproofing in yet. So how do we make sure we get things scheduled properly and we get the GC to slow down? Because remember, we're behind schedule the second we put the shovel in the ground. So next slide, Todd. Warranty requirements. I'll focus on a couple of these things. Everybody's program is pretty similar. There's an authorized contractor. There's an independent inspector, which we'll talk about. We'll talk about pre-con meetings. They'll give you an inspection reports and they'll go through post-construction stuff. And then they'll issue you the warranty, which is great. And you want a manufacturer who's going to, respond to warranty claims and leaks. But you also want to make sure that the building doesn't leak to begin with, which is more important in my opinion. So if you go to the next one, Todd. These independent inspectors are there to inspect not only the waterproofing when it's done, when it's being done, but also after it's done. Because a lot of damage happens because other trades are there. And you'll see in this picture, we've got a welder coming. He's going to come and he's got to cut that off. And so you got sparks flying everywhere and unprotected membrane everywhere. So the goal here is for an inspector to see something like this and shut it down, make sure the membrane's protected. So independent inspectors play a vital role because not everybody has the same motivations. This guy's motivation is not below grade waterproofing. This guy's motivation, I was paid to cut this off. I'm going to do it as quick as I can and get out of here. So the inspector catches a lot of that damage. Go ahead, Todd. Baseball fans. So given that this is virtual, I'll ask the question and answer it. But what's going on here is, yes, they're exchanging the lineups, but they're going over the ground rules. In baseball, every stadium's different. All of the rules are different. The stadiums are all different sizes. A ball that hits the roof in Tampa is ruled differently than a ball that hits the roof in Houston. Much like construction, every job site is different. If you took the same GC and took the same design and built two separate buildings right next door to each other, I guarantee they would be built differently at different speeds, at different costs, and with different methods, because every job site is different. So we want to get these ground rules out, and that's why we want to have pre-con meetings. We want to talk about pretty much everything that could go wrong in the job and get it detailed out front. These are not check the box meetings. I've been to a million of those, specifically for air barriers and things like that. And it's a 10-minute meeting. Yeah, we check the box. That's not what we're looking for. We're looking for going over everything that we just went over. What about the temporary power? What about braided cable? Who's doing the water stop? Where are the penetrations going to go? And just making sure we get all of that taken care of up front, so that when these things happen on the site, we can go back and say, no, it happened right here. So pre-con meetings are important. Go ahead, Todd. The summary, every waterproofing membrane works. I don't care who the manufacturer it is. I don't care if it's GCP, Setco, Carlisle, Henry. They all work because they've all been tested to prove that they work. They've all been in a lab, and they all can work in a lab setting. Failures occur because of site conditions and detailing. Has nothing to do with the actual membrane. We don't sit there and say, oh, the membrane is this or the membrane did that. the membrane typically won't fail unless something happened to it, a site condition, some type of detailing defect. Always specify approved applicators, pre-con meetings, and independent inspection. And in fact, those are requirements to get the warranty, so they're going to be in the spec anyway. But a lot of times you guys will spec something, and you'll get into a sub who wants to use a different product. Mainly, it's money motivated. They'll try to substitute something in cheaper, which is fine. But when you're looking into the substitutes, find out which ATM covers this. Go ahead, Todd. You're still on mute, Todd. So find out which ASTM covers this, okay? So this happens to be the Verizon building, right next door to the Verizon building in DC, right down in Georgetown. You see all of those conduits coming through. They were cast in a beam at some point. And if you look at all those conduits, half of them aren't even together, but we couldn't move the conduits because in one of those conduits was the 911 call center for DC. So they couldn't take any of that because the 911 phone line basically ran into this. So this bisected the corner of the building, and we couldn't move it. So now what do we do? And we had to figure out a way to make this building or this watertight and make this corner watertight. So what they ended up doing is they poured this as a beam, and we took the membrane up, turned it on the underside of the beam, wrapped it, came back around, and then got to the back of the wall again. They had to remove all of this rebar because this was all done. All this rebar was done, prior to them figuring out, oh, wait, we can't just waterproof this. So you need to make sure that whatever manufacturer you're using has real world experience that can handle situations like this, because it doesn't matter what product you use. There isn't an ASTM in the world that covers this condition. I can guarantee that. Go ahead, Todd. And, finally, we live in a world of not my job. So this guy's job was to paint the line, not move the tree. So that's what he did. And I bring this up because on every job, not every job, a lot of jobs, we run into situations where something is either designed wrong, some condition is wrong, it's different than what it was supposed to be. And I have a lot of contractors who will intentionally install things incorrectly. And I say, why'd you do that? And he said, that's the way it's designed. That's the way it's drawn. We're going by plans and specs. And then if it leaks, it's not my fault. I did exactly what you guys told me to do. And it's CYA and it's crap and I hate it, but it's reality. So we're trying to eliminate as much of not my job as possible. There, I think I got muted there for a second. It's unfortunate that everybody kind of lives in this world where if I suggest something that doesn't work, then I'm at fault. But if I do something that I know is not going to work, I'm scot-free. So we're really trying to eliminate not my job syndrome. Go ahead, Todd. You're still on mute, Todd.
Hey, Chuck, while we're waiting, I just want to say hello. It's Steve Gordon. How you doing, Chuck?
Steve, I'm doing well. How's your handicap?
My handicap's okay. I'm going to play this week, play Friday, I think, a little bit, while Todd's doing it. All right, I'll get off the thing. Just want to say hello to my old friend. Thanks.
Appreciate it.
You're still on mute, Todd.
Christine, can you unmute him?
No, I cannot, since he's in charge of the meeting. I think you need to open up your Teams dialogue and then click the microphone button. In the bottom where it has a Teams icon of your screen, where it's like orange. Yeah. And then, yep, click on that. And then the microphone up next to leave, 2 over from leave, to the left. Yeah, that.
How did that get clicked? Is it working now?
Yes, we can hear you.
Oh, thank you. All right. So, so that was sort of, Brian, great job. I appreciate it. That sort of concluded the AIA portion of the presentation. So I just wanted to spend a couple of minutes here while we still have some time talking about, you know, the Henry solution. So, you know, this isn't the bleeding edge of technology. This isn't a new product or a new system. So we have had a relationship with this German company called Max Frank for about 20 years. We've been selling them our Blueskin WP200, which is our 60 mil peel and stick sheet membrane. We've been selling them our water stops. So we've had this relationship with them for about 20 years. So they have a product called ZemSeal, and we've rebranded it as Henry Blueskin Pre-Seal. So over in Europe, they've had over 20 million square feet of the system successfully installed. I guess I know where your background has been as far as blindside systems. There's another competitor, Brian mentioned GCP, that make an HDPE sheet. So this is somewhat familiar or similar to the GCP pre-proof, which is based on HDPE, but is polypropylene. And one of the huge differences is it's not only adhesively bonded, but it also has a mechanical fleece that the adhesive is fused into. So there's both an initial bond, a mechanical bond, but then there's a subsequent chemical or adhesive bond. So it's a rather unique system. There's 2 thicknesses. There's the Blueskin Pre-Seal 435, which would be sort of your go-to for underslab. It's 43.5 mils thick. The polypropylene is 35.5 mils. So it's a rather thick layer of plastic, which is doing the lion's share of the work. And then the adhesive saturated fleece is bonded to that polypropylene. So another nice thing about it, it comes in rather wide rolls. So either 1 meter or 2 meters. So either 3.3 inches or 6.5 feet. And it's rather lighter weight because of the polypropylene and less adhesive on it. So it's a rather light roll. Contractors like working with it. The polypropylene is more malleable and workable in cold weather conditions. So like that project I was at up at MIT a couple weeks ago, it was cold. Contractors enjoyed working with it, and it's compatible with our other systems that tie in, like the Blueskin WP200, and as Brian noted, it can tie into our plasma deck water systems as well. So the thinner version is more for vertical applications behind walls. It's 32 mils thick, so that's the Blueskin Pre-Seal 320. Also available in 3.3 or 6.5 foot wide rolls. So that's just just wanted to share some basic information. Here's a graphic of some installers rolling out the 2 meter wide roll. It has a double selve edge, so it's got a selve edge facing up here and the selve edge facing down on the other side of the roll. So when those 2 sticky selve edges come together and that gets rolled, it's fully bonded. And then there's additionally some tape, both a double face tape and a single face tape. The single face tape has the same adhesive and fleece, so it bonds to the concrete. So there's just some accessories. And then we have our 925 sealant that we have in 2-gallon pails for doing detailing, and all of our drainage composite and all of our other accessories. So here's a couple pictures of that job I was on up in Cambridge, Mass at MIT. So you can see that we have our own logo on the membrane now, the Blueskin Pre-Seal 320. We also have some great technical support. This gentleman here, Jordan, he's come over from GCP. He's instructing the installer there. This other project here was an underslab installation at Yale up in New Haven. Connecticut. So we've built quite a nice project reference list. So again, this isn't a new system. It's newer to us. We've had wide acceptance with the building enclosure consultants, the spec writing firms, and we're off to the races. So it's all good. So that concludes the presentation. Anybody have any questions about the system or blindside waterproofing or building enclosure?
Hey, I just want to add one thing as an old guy here, that what you really get out of this is 80 years of experience of PPSI. Brian's a little younger than me, but he's got 30 years of experience. And so between me and him, and you got young Dan, you got a lot of experience, and that's what makes the job successful. Can't get that on the internet. Thanks.
Yep. Appreciate it, Steve. There's Brian's mug shot again. I put you back on the screen there, Brian. If anybody has any other question. Oh, now you're muted, Brian. There you go.
That's what people want to see after eating, my face. So that's good.
Exactly. Well, it keeps it real. We're, even though we're virtual, we're still real.
Yeah.
Yeah. Anyone have any other questions?
Yeah, I have a question. This is John Torti here. How are you guys? Great presentation. Can you hear me?
Yes, we can hear you.
Yes.
Thank you.
So now that you've told us where the magic is, let me ask you a simple question. What do you want us to do about it? I'm serious about that.
That's a great question.
A lot of whining and complaining going on here in this presentation, and I understand why, and it's legitimate and all of that. But it seems to me that if this kind of CRAP comes out of most sheeting and shoring adventures, then our specifications aren't tight enough for the sheeting and shoring. So how could you help us with that?
So essentially, we have been working with the sheeting and shoring guys for several years, and we are getting a little bit of help from them, to be perfectly honest with you. The main thing is there's nothing you can do about it. We're trying to make people aware that those are what the issues are, and we've seen what those issues are. And there's a lot of other manufacturers out there right now who are going to architectural firms, to contractors, to owners, trying to save them a nickel, save them a dime. And the DC market's unlike pretty much any other market. The sheeting and shoring in this market is by far the worst in the country. So we're just trying to bring awareness that these are what caused the problems, and you may be able to have a manufacturer show up on your doorstep and show you all the ASTM meets, and it's the greatest thing ever. But understanding that what we're trying to do is we're trying to show you guys these are where the real problems occur. You need to have solutions for these problems, not that it meets 231 feet of head pressure, which, given some of the pictures you saw, doesn't really mean anything.
Excuse me, but as you said, all you guys have good product lines. All right, I'll take your word for it. Your word's not mine. So let's say that, let's assume that that's true. So the question is, if I have to, do I install it on a rocky road, or do I install it on a glass sheet? So the question is how to get close to the glass sheet. And so what is the sheeting and shoring specification that allows the hammer of the developer contractor to ensure that specification?
So the best thing that has happened is your sheeting and shoring, the actual lagging boards themselves have gotten infinitely better in the last 7 years. The spacing between the boards is now, I think your guys' specs might even be 1/2 inch. It's either 1/2 inch or 1 inch. That's not the issue. The issue comes when they can't drive the pile properly. And I'm not sure that there's anything that you guys can do about that. You know what I mean? I don't think that you guys can say, you can't use a steel pile that won't twist, or you can't use a steel pile that misses, because you don't get a second chance. Once they drive it, it's down there. And sometimes they drive it in those locations because they have to. They can't get it back far enough to the property line. So, you know, I don't know if that's something you guys can work with them on, knowing exactly where the piles are going to go or they need to go. But we see it a lot of times where the piles have to come in a little bit. It's a mid-lag pile, and now we have to have the rebar running through it. And it's just an unforeseen condition. And I don't know that there's anything you guys can do about unforeseen conditions.
I don't think that, I mean, we need to draw where it is or where we want it to be. And if we don't do that, shame on us. But if they have to move it, normally they ask, but maybe they don't. And clearly, if they have to move one pile, forget about it. They're not going to ask. It's just going to go in. Well, the question then becomes, who pays for the remedy, and in what process does the remedy occur in the process? Is it just an ad from you guys, or is it an ad from the onto the shooting and shoring guy to fix it to please you guys?
It typically is done by the GC, and depending on how egregious it is, they may pass that back to the shooting and shoring guys. But the waterproofer has in his contract that he needs a substrate suitable for waterproofing. That's almost in every contract, and almost every installer excludes surface prep. So then it comes back to the GC to provide it, and whether it's, you know, egregious enough to go back to the shooting and shoring guy, or it's a little bit of plywood that they can put up themselves, that be, you know, that's a decision that they make.
The waterproofing subs, in essence, get to take a look at what they're doing, and they say, I can do this or I can't do this.
Correct.
And then it's up to the GC to fix it.
Yep.
And then it's up to the GC to either swallow it, go back on the shooting and shoring guys, or ask the client for more money.
Yep.
And hey, John, if I can add, you know, something along the lines of what Steve Gordon was saying with the 80 years of experience in PPSI. Well, Henry Company has a very deep bench of experts, and we actually have 2 Henry employee field tech reps. You know, one is local in Maryland, one's a little bit further north, who had like 15 years experience with GCP before coming over to us. So we have our own, you know, Henry employee field tech reps that are dedicated to make sure that the installation goes properly. So
the installation of what?
Of our system, and I know your question was about the supportive excavation and the sheeting and shoring. That's out of our control. And as Brian said, you know, things are improving. And I guess to the extent that you can write a tight spec around that, that would bode well, you know, for the owner, your client.
Yeah. Hey,
Well,
John,
I would repeat to say, we're not the ones that are going to write that tight spec. You're the guys who, as I've been hearing, have all of this knowledge, all of this. So you need to offer it up. I'm looking to you.
Yeah.
Hey, John, this is Steve Gordon. I'll interrupt quickly. I've tried for a long time. The only way to do it, even start it, is take all the manufacturers have certain specifications. The sheeting and shoring, who's designed by the foundation contractor, those specs have to be included in their end of the job. And if it's put in there and the owner understands it, so theoretically, if the piles are put in wrong, the sheeting and shoring guy is responsible for it when he drives the piles. If he knows it up front, in theory, it says you got to do this, then he has to do it, and it doesn't fall on you, because those piles can be driven long before you guys are involved in the project.
Yeah, no, you're right. You're right about that. It's rarely in the sheeting and shoring specification is really something always separate anyway.
Yeah, and so the only way to stop this, I'm looking at this a long time, is that somebody has to put a gun to the sheeting and shoring guy's head with a spec. If you don't, you have to have this done so we can do the waterproofing. And as long as the owner understands, he doesn't come back to Brian and beats him up. I don't want to spend the money to do this. He goes back to the sheeting and shoring guy and says, you didn't install it right. You
And
have
then-
to fix it. You knew it up front when you bid it.
Yeah.
That's
So
the
we
only way to do it.
Listening to you guys complain. This is a big issue because, you know, waterproofing has become the king and the queen and the jack of all construction these days. Whether it's below grade or above grade, this is the issue. This is what winds up in court all the time. So this is very important. I thank you all for bringing it all to our attention.
Thank
I got to
you.
run. I got to get to New York in 30 seconds. Bye-bye.
Take care. All right. Anybody else have any other questions? Did anyone make any comments? Show conversations? Oh, great presentations. Look at that. All right. Well, we'll go over these if there's anything since you're probably, oh, muted. Okay. All right. Well, any other last questions before we sign off? I apologize for my technical difficulties. All right. Thank you very much, Christine. We'll get the Form B from you with all the participants, and we'll go from there. Thank you very much.
Thank you.
Thanks,
All right.
guys.
Have a good rest of your day.